This is going to be pretty unstructured today. No presentation, no slides. We're just going to hang out. We're going to talk a little bit about Aleo. I know some of you, if not all of you, are probably like hacking. So I think my biggest goal really is to just get you guys the materials you need to be able to successfully hack, earn an Aleo bounty, et cetera, et cetera. Hopefully you'll also learn something while we do that. I guess the main thing that I'll show off today that I think is probably most useful to people at a hackathon, one, of course, are the developer docs, and two is a new addition to our web SDK that we recently launched called Create Aleo App. And this works very similar to Create React App. I know many, you're probably all familiar with that. Just polling the room, how many of you guys are planning on working with Aleo this weekend? Cool. So you guys are probably interested in ZK or new to ZK or something like that. And I think that's exactly the kind of like hackathon participant that we're looking for. The main thing, as you can see here on the screen, what Aleo allows you to do easily is build full stack private apps on a ZK layer 1. And the way that we make this easy for you is abstracting away all, welcome guys. The way that we make building ZK apps easy is abstracting away all the underlying details so that you don't have to think about which prime number do we need to choose, what curve should I use, what proving system should I use, right? And I think those are, having to understand all of those individual decisions, how they work, what can go wrong if you choose one or the other, I think is one of the big barriers of entry to being a ZK developer. And so we're looking to abstract those away and make things easy for your everyday dev to get started. By the way, my name is Craig. I'm the lead dev role here at Aleo. So if you do have any questions, kind of the rest of the weekend, I'll put my Telegram and Twitter up on here afterwards, and we can check it out. So with that said, I mentioned that we'd check out at least two things, right? So I think number one, your number one place to go if you want to learn, if you have a question, the first place you should go to figure out if your question's already been answered or if it's been documented is developer.aleo.org. There's a wealth of information here, both about Leo, about Aleo instructions, etc. So we can jump in here and kind of let's just take a quick look at what do the docs look like. They're nice and colorful. They have syntax highlighting. We love to see that. We kind of, it's what you'd expect from docs, right? We outline all of the various features that are available, some of our data structures. Some of them are a little more complicated. So we talk about that. For example, records, right? If you're familiar with our architecture, then you would know that it's not based on an Ethereum-like account model. However, instead, if you're familiar with Zcash or Bitcoin, our model we call the record model looks a lot like UXTO, where you have an input record that is spent to execute a transaction, and there's n number of resulting output records, right? A really important and very important feature is, we like to say that Aleo is ZK by design, right? So you get privacy for free just by building on the infrastructure stack. However, you might want to do public stuff too, right? And so we do support both public and private use cases. And the way that is achieved is via these functions that I'm going to go over real quick. So there's two important function types that if you're going to take anything away from this talk today, these are the two things I'd like you to understand. One is a transition function. A transition function we can think of as the way that we do private computation. In Aleo, we have a decentralized prover network that does off-chain executions, wraps those executions up into a proof, sends it back to the client signs it with their key, and then submits the signed proof to a consensus network that are regular proof-of-stake validators using Bullshark and Narwhal, like you might already be familiar with if you've looked into Aptos or Sui, right? So we have a proof of work style execution network. You can think of this as like our compute layer, generating proofs which are being signed by users and then sent to validators. Welcome. Hi, everybody who just walked in. Thanks. So transition functions are how we achieve private computation. So I mentioned the prover network. When we execute a transition function, this is sent to the prover, and it generates a proof, right? running a transition function will generate a private record, which is wrapped into a proof, encrypted, signed, and sent to validators. So what about public state? If we want to manage some kind of public state, if we want to do a public transaction, maybe we don't want everything to be private. We can do that with a function called the finalize function. You can see a little more bit of the syntax on your own time. I'm not going to go over this too much, but we can look at it as an example of how could we implement like a private transfer, public to private transfer, right? So we want to publicly initiate some transfer, but privately transfer the balance, so that the resulting sender, we have no idea how many tokens that he received, or how many, where they go from there. And so the way that can be achieved is by using this finalize function, right? So we can store things in a mapping. This example doesn't have all of the things I'd like to see, so I'll jump into we'll talk about a token in a minute when I jump into a more full-fledged example. So finalize functions essentially are just on-state actions. You're submitting this proof along with a bunch of metadata to be validated, and what is validated is the proof, yes, and then the metadata are essentially the on-chain actions that you want to do, that the validator will execute, which will result in state changes to the network. So let's, if we wanted to implement a private token, let's check out what that might look like. I'm going to pull up VS Code here, and I have a handy set of workshops, which you can find if you're curious at, I will Google this. So Aleo HQ/workshop. There's a repo that's full of these workshops that I'm going to go over real quick. So if we wanted to implement, let's say, a private token, right? There's two components to this. One is mapping addresses to balances publicly, if our token has a public component. And then there's also handling private transfers between users if they're interested in that, right? And so we're going to go over how to do both of those real quick. So one, we need to define a token record. This is essentially the data structure that we'll be using. It's pretty straightforward. We have an owner and we have an amount. This is like the most bare bones token possible. You can imagine we might also have a trading symbol or something like that, right? This would look like ERC20 or whatever have you. So let's first implement minting tokens publicly. The way that this would work, I mentioned before that in finalize functions, that's where we're going to be doing public on-chain state transitions. So we would simply get the amount that we're intending on sending. Our transition function just forwards it to the finalize function, and then we set this on-chain mapping with the appropriate addresses, the receiver, and the balance. Now, if we wanted to do a private, we don't include a finalize function at all. And you'll notice one thing to point out about transitions and finalizes must always follow a transition. And so the way to think about that mentally is we do something privately in a transition, and then there is something public about this private transaction that we might want to put on chain. Maybe we store an ID, maybe there's a hash, whatever have you. So it's do the transition, then finalize. And so finalize functions always overload their respective transition. So in the private minting case, all we need to do is just return this token record. And because it's all encapsulated in this transition function, we'll have a private record wrapped in a proof that no one can see who it was minted to, no one can see who owns it other than the receiver. This owner flag here in records is like a reserved word. And essentially what this is saying is that whatever address is the owner is the only one on the network who can decrypt the record and see the plain text of that record. So of course, you can look at any records that you've interacted with and you own, but no one else can decrypt them because, yeah, they're encrypted. So you can imagine transfers are pretty straightforward. If we wanted to do a public transfer, again, we're not doing anything privately, so we're kind of just forwarding to the finalize function. Here, we calculate the sender amount, we calculate the receiver amount, and we calculate the difference. We set the new balance of the sender. And similarly, we calculate the difference. We add the new amount and the old balance, and we set it. Private transfer looks very similar, except for we're doing it completely in a transition function. Right, so this is pretty high level. This is Leo, the language that you would be using to write circuits. This gets compiled into an intermediate representation that we call Aleo. That looks very much like assembly. It's still pretty high level for assembly, and then ultimately this gets executed as circuits. So let's look at a more interesting example real quick. This is token. Again, you can check this out at aleohq/workshop. But what about like private voting? How could we do that? By the way, is this large enough for you guys to see? Is that better? That's too big. This is too small, right? So if we want to do private voting, right, how could we do that? So the idea is that we want to be able to publicly store proposals. Like you should be able to go on the website and see the proposal, read the text of it, right, and make a decision on, hey, this is cool, I want to vote on this, I'm involved in this DAO or this community, but I shouldn't be able to see how you vote, and you shouldn't be able to see how I vote, but you should be able to see how many yeses, how many nos, and ultimately what is the result of the vote. So we're going to build that, or this workshop implements that idea. So first, we have a data structure to store the proposal information, simply title, content, and the original proposer. And then we also have a private record that maps the proposal info to an ID. So publicly, what we're going to store are the proposal info, right? And then we also need to implement like a way to vote privately. So to submit a vote, and we're doing that with this ticket data structure here. And then we have public mappings for agrees and disagrees. So if we want to propose a proposal, first we're going to hash the ID, the title, and that's how we're creating a unique ID. Maybe not the best way to create a unique ID, but in this case, it's an example. Don't use this in your production app. And then we return a private record that is then finalized. So we're just mapping the ID to a private record. If we want to create a vote, we create a new ticket record, and then we finalize this ticket so it can be used later when you actually make a vote, right? So this ticket doesn't yet have a yes or a yay or a nay attached to it, right? So we're here. And then we create a new ticket. We add it to this ticket's mapping, because we do want to publicly keep track of how many votes were made. We want to keep track of how many yeses, how many nos publicly. It's the decision and the individual voters that we're keeping private. And that's this part right here, right? The owner of the ticket is being returned as a private record, so no one can see that. But you can see the proposal ID, of course, that you're voting on. And so in the case where we agree with something, right, the owner of the ticket is already private, so we don't need to do anything with that. But we do want to store, for that proposal ID and this voting ticket, increment the number of agree votes by 1. Similarly with disagree, the exact same thing, right, but just a disagree. Cool, so I want to stop right here before I get into anything else. It's a super short workshop. I only have 20 minutes. I will show off one more thing, which I think is useful if you're hacking with Aleo this weekend. And what that is create Aleo app. This is how I would recommend that you get started with your project. It looks just like create React app. The only requirement is you have Node installed. So let's just run through this real quick, right? Let me find another. So we run npm create Aleo app at latest. There's a couple templates in here. So we make an Aleo project. In this case, I'm going to use React, JavaScript plus Leo. I'm going to go into the project and open it up into VS Code. And we're just going to go over what I just did. What did this generate? So what this generated was, and while we wait, so while that goes, we have a Leo file, a Leo contract, right? And we also have a Node app. It's a Node React app that implements some functionality to interact with the program that is in this repo here. And so once this install is done, I'll show you that we can spin up the React app and we can interact with the contract very quickly. And really the idea here was to just reduce the barrier to interacting with a contract that you might write on-chain. So if we wanted to execute hello world, go in here, right? I think they recently removed this function, so it's actually called run now. Well, while I was sleeping the other night, I had a workshop that I gave yesterday, and they pushed a new version of the SDK that removed something my workshop used while I was sleeping. I love the time difference here is very fun. And so we debugged it live. It was an hour workshop, so we had the time to do that. But essentially, yeah, like what we have here is a simple React app and a simple, kind of hello React, hello Leo, but they're connected to each other and they're talking to each other, right? So this is the main thing that I really wanted to show off, other than the docs, and just talk a little bit about Leo. 20 minutes is pretty hard to go over everything, so I'm just gonna, let you guys kind of guide the rest of this and ask any questions that you might have. Thank you. Any questions? And in case you have any, yeah, please.
What kind of math functions do you support? Like, can you do square root, square, floating point numbers, all of that?
So we can check out the docs to answer that question, right? There are a bunch of arithmetic operators. So you can see more detail, exactly what data types, their syntax, etc. So we do have square roots, inverses, squaring, etc.
And what is a field? Is that not an integer? Is that
It's like an arithmetic field, right? So like an elliptic curve cryptography. Okay. And you can read a little bit more about that in the data type section. Yeah. So all of this information is there on the docs. The docs are very extensive. Highly recommend you check them out. There's also the SDK I went over. I don't have a lot of time to go over, but there's a whole tutorial you can follow if you go under the SDK docs. That'll guide you through it, show you how to use it, et cetera, et cetera, et cetera. One last thing, if you need to get a Leo wallet, go to bit.ly/Leo workshop. Because the faucet's been a little unreliable lately. So go here. I created a whole, I wrote some Python scripts to automate wallets. I filled like hundreds of them and then wrote a Google form automation to like send you guys a wallet in your email. Of course, like don't use this private key in your like production app, but for your hackathon purposes, it should be fine. There's already credits in these wallets. You'll just get one in your email. I'll show you how it works. So if I just do craig@aleo.org, I go to my email. Just maybe not, it's the wrong email. Where I go to my email. Yeah, it's not working, so I will fix it in the next 5 minutes. But I'll show you an example of one of these when it works. Let's see. It looks something like this. Yeah, so. It's like 25 credits, which should be more than enough to deploy a program, to do some executions. And if you need more, like please reach out. My contact information is at Craig JSON on pretty much all platforms. You can follow me on Twitter. You can follow me on Telegram. Feel free to just like reach out, and I'll try to help you as best as I can. I'll also be hanging out at the venue for a little bit as well. So if you want to come and find me in person, happy to chat. But I think with that, I am just about out of time. So I think I have time for like one more question, if anyone has one. Mainnet is coming early Q1. So right now we're looking at late January to February. So right now we're in like late stage testnet. But you can deploy, you can pretty much all of the features you'd expect are there. Where we're currently like onboarding external validators, right? We've been running the nodes, but we have 2 validators that are onboarded, and we're working on, kind of fully decentralizing the network before we go into mainnet. So pretty exciting stuff. Like a box counter? Like an Explorer? Yeah. So there's a few of those. One that you can check out is called Aleo 123. Another is HAMP Explorer. There's also explorer.aleo.org, and there's explorer.hamp.app. So 3 options, all have different features. I recommend you pick your favorite. Yeah, thank you. Also, I believe we have a $5,000 pool prize this weekend. Maybe it's 10,000. I actually forget. But we have some bounties as well. So check them out. You can find them on the ETHGlobal website. Yeah, and thanks for coming. I appreciate you guys. Thank you.